we're going to be talking about UX research in data science. So just as an overview of what we're going to be doing today, we're going to start off by talking about our individual backgrounds, and then I'm going to talk about user experience research and user experience in general. And that will actually segue really nicely into Jason's portion of the talk, because they are related, and a lot of it will help set up some of the key ideas and how data science is applied as well. Anything else?
No.
Okay, and at the end, if we have time, we're going to talk about some jobs that are similar to ours, but aren't exactly ours, and what kind of differentiates them. Okay. So first, about me. I grew up in Peel region outside of Toronto, and I did my undergraduate degree at the University of Waterloo studying economics. I did not know what I wanted to do, but I studied economics anyway. And I knew that I wanted to go to grad school. I did not know which grad school exactly, but I worked for a year or two saving money because grad school can be expensive. And I went to the US to do my grad school at the University of Michigan, which was very expensive. And I did a 2-year degree. It was called a Master's of Science in Information. So I had applied to a bunch of graduate schools for library science, and the University of Michigan had a really prestigious library science school, but they also had 9 different specializations. And since I didn't know what to do, that was great for me, so I could see what the different things I could potentially do with a degree would be. But I wound up specializing in something called human-computer interaction, or HCI, and that's kind of the umbrella field that user experience lives within. And it's basically how humans interact with computers and technology. And during my degree, I was required to do internships, but I also had part-time jobs that were related to my career, and I leveraged both my degree and also those internships and part-time jobs into getting a full-time job later in New York City, and I've been working in New York City since.
Great, yeah. And so like Becky, I'm now currently in New York and been working in the tech industry for a number of years. But unlike her, I actually grew up in the States. I grew up in the New York City area. But like her, I also went to undergrad in studying a totally different field. So I worked as a book editor out of college after studying English at Brown University in the US. Worked there for a number of years, but then I went back to graduate school, decided to switch, my career, and ended up working under a political scientist and learning a lot of the statistics and programming knowledge that I utilize today in my day-to-day as a data scientist. But of course, I didn't explicitly train as a data scientist. It sort of came to me on the side, but I did have those skills, and I ended up utilizing them to do research, write a book. I worked at the University of Toronto at a research lab. So, you can utilize data science skills in academia. And since then, I've worked in nonprofits, tech industries, and, companies that are very large, like Spotify, as well as some much smaller ones like Tumblr and others. So really quite a flexible degree in terms of what you can do with it. But a lot of the core skills are very key, and Becky's going to talk a bit about them.
So we're going to go back to what is user experience research. It's kind of a complicated question, and so I'm not going to give you a straightforward answer, but try to explain it over the course of about 10 or 15 minutes. You can think of UX research as something that can happen before, after, and while a product is being built. Before the product is built, UX research is about uncovering and understanding what the wants and needs of users are. And then once you understand what those wants and needs, ideally, then you create the product. Okay. While the product is being built, UX research is about checking that what is being built. So these might be in the form of prototypes or black and white designs or colored designs. Sometimes they're not interactive yet. You're checking that what people are designing and building actually is intuitive for people to use, but also meets the user's wants and needs that you had previously uncovered in the upfront research. After the product is built, UX research becomes more about evaluating the final product. And some of the reasons why you would want to evaluate the final product is that you might be doing something like benchmarking. So when I say benchmarking, you might be testing the final product over and over again, periodically, like every 6 months or every year, just to see whether or not the product is getting better over time, or if it's getting worse or staying the same. Sorry, the slides aren't appearing very. Okay, I'm going to keep going. And also, when you are evaluating the final product, you're able to identify ways to incrementally improve your product. Once the product is built, it gets harder to make large-scale changes, but you can make smaller ones, like building out specific features, identifying bugs, maybe specific smaller workflows that can be improved. But you can also, once the product is built and you're evaluating it, gather enough evidence for when an eventual complete redesign is being made, the things that were too difficult to change because it was already built, you have freedom to rethink the whole thing. And you have the evidence for why that needs to happen. So I've been talking about user experience. User experience, what is user experience? In case you're not familiar with the term user, a user uses or potentially uses your product or service. And there are different kinds of users, especially when you're developing a product or building a product. You have to think about different segments of your users. One way to think about them is in terms of level of experience with your product. So you might have new users. These are people who've never used your product before. Or you might have expert users or power users. And these are people who might have many years of experience, and they know the ins and outs of your product and all the settings and all of the shortcuts. They're probably going to use your product differently and have different wants and needs compared to the new users. Another way of thinking about users is in terms of how frequently they're using your product. Are they using it on a daily basis because they have to use it for work, and so they're constantly doing it throughout the day? Or are they something more like a monthly user where they don't rely on it for their work, or they only need to check it periodically because nothing changes? Those people will have different sets of uses and wants. Hopefully by this point you have a better understanding of what a user is and what different users might have, sorry, different users will have different ways of using your product and different needs. But what is the experience component of user experience? So the experience is talking about the experience a person has when using a product or service, and oftentimes UX is applied to technology products. So the most common product that a user experience researcher will work on is something called a graphical user interface, otherwise known as a GUI. And these are what you're probably most familiar with. They're things like apps, websites, or desktop products. So my particular experience happens to be that most of my work has been involved with graphical user interfaces, especially desktop products. Other types of technology that researchers also work on could include things like voice assistants or voice interactions. They could also work on video game systems or virtual reality like an Oculus. They could also be other types of hardware, especially connected devices like speakers, stereo systems, or even kitchen appliances. Now, how does research influence the design of a product? So I'm going to give an example. Imagine that we're studying iPhones and you're trying to understand what the wants and needs of someone using an iPhone is. And we're going to narrow it down to a particular want. Say that the person wants to make a phone call. And you've done some research. And one of the scenarios that people have when they want to make a phone call is that they need to tell a friend that they're running late to a meeting or a dinner or lunch, something along those lines. So you dig a little deeper when you're doing the research and you realize that the friend that the user is trying to call is someone that they've actually called yesterday or the day before. And it's also someone that the user is going to call all the time. So using those pieces of information and assuming that what you user is common and reflects the experiences of other users as well, you can start to design and think about product solutions. So you know that this friend is someone that you're going to be that you've called recently. So you might decide to make something like a recents list, a recent call history. And so it helps the user be able to make that call faster by simply going to the recent list, finding the friend's name, and calling directly from there. The other piece of information that we have is that this friend is someone that they're going to be calling all the time, not just for telling them that they're running late, but they're probably going to want to be able to quickly call them again and again. So you can create something like a favorites feature where you can add people that you're likely to contact a lot into this favorites list so that it's always easy and handy instead of having to search for them either through recents or through your contact list. So those are a couple of examples. But imagine that instead of the need to tell a friend that they're running late, imagine instead that the need is to actually call 911 because the person has been in a car accident. As a researcher and as a product person, because researchers often work with product people, you would have additional questions before you want to make any design decisions or product decisions. You would want to know things like, are they able to use their own phone when they need to make that call, or are they using someone else's phone? Is this person hurt? Will they be able to use both hands in order to make that phone call? And also, how likely is it that they're going to have to do this? How often will they have to do this? Is this once a month, once a year, once every 5 years, never? And that kind of information will help inform how any designs get made, but also whether or not it's worthwhile to make a specific design solution for this problem. Having said all that, how do you actually gather data from users? So there are these things called research methodologies, and there are a lot of different research methodologies that I'm not actually going to go through each one with you today, but these are some of them, especially the most common ones. But know that there are a lot of different ways to gather data, and it's up to the researcher to figure out which method is best for this particular problem, especially given the time constraints or resource constraints that they have. And now kind of what happens on a day-to-day basis for a user researcher or a UX researcher, especially when it comes to a study. So these are generally what the steps are. You have to, at the outset of a particular study, you collaborate with your stakeholders, you identify the research questions, you design your study plan, you are responsible for recruiting your participants, executing the study, analyzing the data, and then reporting and documenting the findings back to the team. Now, what are some of the traits of a UX researcher? How do you know if this is something that you want to do, or even that you would be good at it? So empathy is a really important part of user experience, putting yourself in someone else's shoes, especially as the researcher, because you're most likely the person who's talking the most to your end users. You have to be the voice of the user to the rest of the organization. And so it becomes very important for you to really understand them and also to voice that back to the rest of the company. You also have to be you have to have problem solving skills, because not everything is going to go right. There are going to be all sorts of hiccups along the way, and you'll have to figure out how best to solve those solutions, to solve those problems. Being inquisitive is important. It's all about asking questions. I'm asking questions of my stakeholders, of the users I talk to. Being inquisitive is an important skill and trait. You're going to have to collaborate with a lot of people, and you'll also need to really enjoy technology, because technology is always changing. And to a fair degree, as the researcher, you have to understand how the technology works when you're talking to the people, so that you can understand why certain decisions get made the way they are, but also perhaps negotiate with people on what kind of fixes are possible. And what are the skills and knowledge that you would need to be a researcher? So some of the human-computer interaction fundamentals will be important. You can acquire those either through degrees or boot camps, or even on your own by reading books and learning. You'll also need to know the different research methodologies, what's the pros and cons of each and when to use them, experimental design, analytical skills for combing through the data, communication skills, some statistics. So most UX researchers are qualitative, but they will sometimes be asked to do quantitative work as well, which Jason is going to talk a lot more about. And then design skills and computer science skills are optional, but they're very beneficial.
Great. Well, thanks, Becky, for that segue. And so I'm going to talk a little bit more about data science, and in particular, a field within data science known generally as product data science. You might have heard about data science as sort of this buzzword about, how we're collecting lots of new data points and signals from people, users, about how they're utilizing apps and programs to think through the best way to build these things for them, either through recommendations or new features. But first, before we get into that, whole thing about programming and statistics, we could walk through a brief example of how we actually approach the problem. So going back to one of the questions that Becky had is, oftentimes we're sitting around with a team of technology folks inside a company, designers, product managers who are in charge of building, pieces of technology and features and apps, and other fellow engineers. And we're trying to think about, how do we know what to build next? We have all this energy and all this time. What should we do? And so the obvious answer is build what the users want. But how do we know what users want? So as Becky mentioned, one of the ways that we could do that is to ask users. And there are many UX research methodologies for asking users directly through interviews and through surveys and so on. Another approach is potentially we just watch users. What if we just give them an iPhone and say, go at it, let's see what you actually do with it. And then we could think through, what is it that people actually want out of this product? And so that's very reasonable. We can directly ask people, put it in front of people and, just really voice to them, what do you want? But the problem is, what happens if we want to ask, say, one person from every country, because a person from, say, Korea is not going to use the same product the same way that someone from Canada might. And imagine we want one person from every country, but what about, say, every country, across different age groups, across different, backgrounds, across different experiences. Now it gets really hard to actually go out and find so many different kinds of people and to ask them directly. And so, just say, for example, let's say you're designing an app that's for sending messages in your iPhone. And there are perhaps many ways to send a message, but maybe there's one way where you actually type in a message using characters, and another for sending voice messages. Now, how would we actually go about collecting the right amount of data to figure out what it is that people want to utilize your product for and how they want to utilize it? Do they want to use typing or do they want to use voice? Again, we can ask people, hey, do you like typing it in or do you like saying it? But another way you do about it is actually just build the app, build the feature, and then start to passively ask users by logging that information, sort of monitoring and tracking in a very responsible way without collecting personal data. And so an example of what that might look like would be sort of this table on the right, where we have what looks like a long Excel sheet, which is in very searchable formats that we collect in at scale, where we have sometimes millions or billions or even trillions of these kinds of rows capturing each of these actions that users are taking. And then from here, we could start to then derive patterns and insights. We could say, for instance, oh, hey, based on the data that we've seen when we analyze it by different user groups or cohorts, we could see that looks like maybe Korean users like to use the voice feature more than they do than users from, say, the US or Canada. But what does that mean? And that's where it's up to us to work with the user experience researchers to really think through, is it because that the text feature doesn't support Korean language very well, or is it possible that Korean users like preferring voice? And maybe we should set it as the default. And so once we have those insights, then we can actually deploy those insights into actual changes to our product and app. And here we can do, utilize tools and methodologies like A/B tests. You might have heard about this, where we have one version of the app for some people, and in a totally random other set of people, we give them a different version with a slight change. And so one example might be, let's set it the default to be text typing for one set of users, and then the other will have voice as a default. And then we can see which one is better based on so-called metrics that we propose. And a metric is basically just a word for an outcome that we think is good. And so an outcome that we think is good might be sending more messages. And so we could basically compare which version of the app that we've designed causes people to send more messages. And then we could use that to think through, did we do something that was actually positive in the app? And so what does a product data scientist do? There are a number of things, including helping to think through how many users might utilize this product, thinking through where in the app or in the software that users have trouble getting to the next step. Like the example before, finding differences among different kinds of users to help us think through, are we doing better amongst certain populations versus others? And then once we have those insights, then it's thinking about how do we fix those solutions? And so we work very closely with designers, engineers, and other researchers to come up with those ideas and then actually implement them into code. And then when we do implement them, as I mentioned, we can do things like A/B tests, but other types of methods as well, as mentioned here in the slide, that help us figure out, was what we did correct, or should we roll it back and leave it as it is? And so some of the skills and knowledge you need, obviously you don't have all these when you start off right away as a data scientist, but over time you'll eventually build up some of these skill sets, including programming in a number of different languages that folks use, statistics, that you really should have a sound grounding in stats and basically understanding how do we get real results from the data that we're seeing. Experiment design, so this is similar to just like you had learned about experiments from your science classes, back in elementary school, thinking through how do you design things in a way where you actually have things comparable and that you can actually come away knowing something real and not get clouded by ambiguity. Design patterns and conventions, very much related to user experience research, knowing generally if we make a certain change, what might we expect? How might users go through this app in a particular way if we present them with, say, a button over here versus a flow over here, and so on and so forth. And then when we have results to share, it's very much about either conveying that information in a clear way or convincing your stakeholders into doing certain things. And so you do need to have skills around data visualization and being able to talk to folks about potentially very complex issues in a non-technical way at times. And finally, perhaps the most important skill or knowledge that you need is you need a sense of curiosity about human behavior. So as Becky mentioned, empathy is so key, and being able to want to really dive into and dig into why people are doing things a certain way is so crucial to being a data scientist.
So these are some of the jobs that we've thought are related to ours. I've referenced product people and designers a lot. So there are a lot of different titles for designers, but they're generally the same thing. UX designer, product designer, interaction designer. They all help to create what these things are called wireframes, and that helps depict the flow of interaction and how you move from screen to screen to screen. Market researchers tend to take the viewpoint of the company and ask questions, often surveys or focus groups, to understand how a corporate strategy might work to a consumer market, or how well known is your brand. So they take on more of the business persona, whereas user experience researcher is really trying to help build more of the product and how best to build the product via talking to users and understanding their perspective. The product manager is going to be making the overall decisions about what gets built, what doesn't get built, what gets prioritized, and communicating it back to their engineering team in order for things to get built on a timely manner.
And with regards to some of these next few, we've talked a little bit about data scientists and specifically product data scientists. But data science is, as probably many of us in the field know, and maybe you all know, it's a fairly new field, and it's somewhat nebulous about what exactly a data scientist is. And so some of these other terms are very related, or it can even be considered data scientists as well. One of them is machine learning engineer. So many of you have probably experienced the work of a machine learning engineer when you say load up Netflix and you have recommendations that pop up right in front of your face. And so machine learning engineers are the ones responsible for building algorithms and models that help think about utilizing all this past data. What should we either show users in terms of recommendations, or how should we nudge users in certain ways through our product, knowing what it is that they might want to do. And so they work obviously very hand in hand with product data scientists to think through, hey, when I created this new recommendation system, did it work? Did it not work? How Should we refine it? It's very much a fascinating field, and obviously one that's quite complex with all the new concerns about radicalization and misinformation. You really need to have also a sense of ethics when you go into machine learning engineering. Data engineering is, sort of the lifeblood of all of the work that we do as data scientists. So they're the ones who are perhaps thought of as the plumbers before the data scientists get access to the data. They're the ones in charge of collecting all the data, making sure it's available to the data scientists and the machine learning engineers, so that when we want to do analysis or for building our models in the app, that all the data is available. And so they're very much responsible for building robust systems for collecting that data that doesn't fall over when you're collecting millions of data points from billions of users, billions of data points from millions of users. And so really a fascinating field if you're interested in more of that nuts and bolts and building these building blocks of data. And then marketing analysts and business analysts do sometimes similar work of data scientists, or especially product data scientists, but they, again, like Becky mentioned with the market researcher, they take more the perspective of, say, the company. So marketing analysts are more focused on getting people into your app and getting them starting to utilize it. And so they might do analysis into, say, ad campaigns or email campaigns or billboards, and then think through where it is in that chain of getting people into your app. Do they work, and what kind of messages work for getting people into your product? And then business analysts are mostly focused on thinking through how do we get not just more users, but the right users, and how do we create synergies between some of our different products, or think about all the different kinds of strategy that we could utilize to get the most revenue out of this product. So they are very key in thinking through some of that more strategy, MBA type approaches to optimizing the data products and technology products that we build.
So that's it. Any questions?
Yeah, I guess we'll open up to either Philip or to the wider audience if you're interested in asking us any questions.
Okay.
And it doesn't have to be related specifically to our jobs, but we also live in New York. So if you have questions about the New York tech industry, you can ask us that as well.
Yeah, it looks like we do have one question. Philip, do you prefer we just answer questions from the chat? Or
Yeah, please go ahead.
Okay.
Oh, okay. Is UX job mainly for young people or a lifetime career you can build up continuously? That's a good question. So I came from schooling, but a lot of people come into especially when I started, a lot of people didn't necessarily have formal training. It was something that they just started to practice and then got into the career. It didn't always have a name to it, but it has developed over time. I guess a lot more of the younger people, they might come from graphics design backgrounds or psychology, or there are ways to get into the industry without having some of that formal background. But you will have to do more legwork in order to get in, especially for the researcher positions, because it's about experimental design. Having higher level degrees does help, because it helps you think in terms of how to structure studies. But if you're more interested in design work, you don't necessarily have to have those higher level degrees as much. There are a lot of boot camps for both of our careers where you can learn some of the UX or data science fundamentals in intensive 8-week programs, 10-week programs.
Yeah, and definitely it's the kind of job that folks, as Becky mentioned, once you have the training, you get into as a fairly young in your career. But over time, as you learn more and more, absolutely, you can continue to build your career within UX. And eventually, some of the folks that start say product data scientists focusing on the UX in technology products, they end up working more as design directors or working as product managers and actually leading product teams, because they have such strong empathy for the users that they're able to think about, hey, now that I know the data side of things, or have talked to people, now I can think about what it is they actually want. Now I'm in charge of not just, say, changing an A/B test that decides whether a button is blue or red, but now thinking about, should this button even exist? And what is the new button that we should be building in? So I think, yeah, definitely it's an opportunity to continue to build your career.
And then the next one, what major may be related to data science?
Yeah, I think this is a really fascinating one. Again, it's one where, since the field is so fairly new, it's only been around for formerly known as data science over the last 10, 15 years. Previous to that, I think a lot of people joke that data science is just a fancy new word for statistics. So a lot of the techniques and tools that we utilize in data science are stats techniques. And so statistics is very much a feeder for working in data science. Now in some universities, both undergrad and graduate school, they do have specialized data science degrees. And but of course, you don't have to have that specific training. You can come out, and a lot of the most successful data scientists I've worked with have like physics degrees, or they've done more social science degrees where they do like say big surveys. And so being able to know how to work with data, but not just any full data, but potentially very messy data is very key to making it in the data science field. And so those are just some of the fields that are related.
The next one, would psychology be a useful degree for UX research and product design? Absolutely. So information science is kind of the degree I got, and within that it was human-computer interaction, but both of these are very much multidisciplinary, and a strong part of that multidisciplinary approach is psychology. So understanding how it could be psychology in the form of neuroscience, or it could be cognitive psychology. It could also be behavioral economics. It's understanding how people react to things. And if it's neuroscience, understanding, for example, the way colors, how people interpret colors and react to colors and react to things like animations. Or psychology, it could be more about, for example, one of the principles of one of the HCI fundamentals is understanding something like chunking information. So people have limited short-term memory, and you want to chunk information so that it's easier to consume. A classic example is a phone number. So a phone number in North America is made up of 10 digits, but it's usually separated into three numbers, 4 numbers, so that it's easier to remember. So psychology is absolutely relevant.
Next question, how could you gain experience within this field? Yeah, that's a great question, because it might look a little daunting seeing the list of skills and recommendations that we have if you want to be a user experience researcher or data scientist. But as I mentioned, it's not the kind of thing where you're expected on day one to walk into a data science job necessarily and have to know everything that we had on that list. It's people joke that data scientists are competent at stats and competent at programming. They're not experts necessarily at either, but more and more, ideally, you want to eventually become an expert in either of them. But as a start, of course, there are internship programs, there are boot camps that give you an opportunity to start to put your feet into the water to see whether or not you like what it is that data science or user experience research is. And you can get some of that more technical training. And then once you have that, other ways that you gain experience is, do little projects on your own. Find a really interesting data set. They're all out there. Say in where we're from, New York City, releases a lot of amazing open data sets, like say the subway times, like when subway trains pull into and pull out of stations. And you could do really cool, interesting analyses that other people haven't done yet. And you can post them and share them on forums that celebrate these kinds of data discoveries. And hopefully you build up a portfolio. And then from there, you can utilize that to get your foot in the door and get an entry-level data science job.
Let's see here. How can you gain experience?
Oh yeah, we did that one.
Yeah, but just to tag on to what Jason was saying, when you are applying for jobs for UX research or UX design, it becomes very important to have a portfolio or sample projects to show, because you can always say that you have a skill, but they actually want to see how you use your skills and see whether or not the way you approach a particular problem is what they're looking for. It becomes very much whether or not you're able to problem solve it in the way that they want you to, or in a novel approach, because creativity is a strong component of what we do. So they want to see the work and how you think.
Okay, next question. As I hear from you, it really looks like it takes at least some programming and math background for some of the jobs that we've mentioned. Yeah, I think generally it is very
For
helpful
data
for data
science.
science. It's yes, for data science and a number of the data science related jobs I mentioned. It is very helpful to have some programming knowledge, because when you are collecting data on the scale of thousands or millions, billions, even trillions of data points, it's very hard to go through and process that and find patterns if you don't have programming knowledge to be able to quickly gather the information, aggregate it, and start to find those sort of patterns hidden in the data. And so, yeah, programming is definitely key. Again, like I mentioned, you don't have to be an expert. There's a lot of off-the-shelf tools that that do a lot of the heavy lifting, but you do need to know how to use some programming to and coding to utilize those tools. And then math is, yeah, absolutely essential when it comes down to actually being able to confidently say, hey, I think I see something in the data, versus it might just be noise, because, you know, people are people. People can be random. You need to have a fairly strong sense of statistics to be able to confidently say, yeah, I feel like this is, you know, something I stand behind.
In terms of UX research, if you're at the academic level, you might need to know a lot more. As someone who's more in industry, it really depends on what your focus is as a researcher. Different researchers will have different methodologies that they're more familiar with. If you are a survey expert, you will probably know more about statistics because you're dealing with larger samples. And so you'll need to know when a difference is actually a difference, or whether it's just noise and within the degree of error. But for more qualitative research, it's not as necessary, but it's useful because you don't know if someone's suddenly going to ask you to run a survey, and then you'll have to run the survey and know how to analyze the data. So some base level of statistics is useful. But if you're more interested in the design side of research of UX, because my degree is actually flexible in that a lot of the people that come from my degree go into design. It's a smaller proportion that go into research. If you're more interested in UX design, you don't need to know mathematics.
About free data sets. Yeah, if you just Google free or open data sets, you'll find some. But yeah, the New York City one, I believe is, if you just search NYC Gov free data sets, it'll show up.
Can I have a question for Becky?
Sure.
Yeah. I just have a question. It's related with my daughter's situation. She did 1 year as computer science, and she found that she doesn't really like coding. She thinks she likes like UX design, and so she's thinking like switching to psychology. I'm wondering, what do you think? Is that a good option, or do you have any advice?
I guess it depends on where she's studying. I assume that she's at university. See if there are specific user experience related courses. Sometimes human factors is an older discipline. It's somewhat related, but not very related.
She's in
Sorry, what was that?
She's in Waterloo.
Waterloo.
Yeah.
I don't remember. I haven't looked into Waterloo and their programs. Unfortunately, some of the more UX related stuff might be in computer science, but you don't necessarily have to, like, they're in the computer science faculty, but she could potentially choose the psychology route, but take just a couple of courses here and there. There are a lot of people that are in design that come from computer science or electrical engineering or computer engineering. Like they know programming, but then they realize that they don't want to program every day for 8 hours, 10 hours a day. They prefer to build things or like design things. But like the programming background actually helps them a lot because the designers work much more closely with the engineers and communicate with the engineers. And sometimes they have to build their own prototypes. And so like computer science is not a detriment if you want to go into design.
Okay, thank you.
Okay, is there any more questions? So thank you very much for everyone to come. And then this will end the section for Becky and Jason. And then I hope that you stay and for the round of sections at 3 o'clock. Okay. Have a good afternoon. Talk to you guys.